So Shana, I'll discuss the question number 3D first. Okay, I'm getting 20 as the answer for C. So I thought of discussing the D first and then I'll discuss about C. So the question number 3. The integers A, B, C, D are each equal to one of the 1, 2, 3, 4, 5, 6, 7, 8, 9. It is possible that two or more of the integers A, B, C, D have the same value. The integer P equals the product of A, B, C and D. That is, P is equal to A, B, C, D. You're just going to multiply all the four for obtaining the value of P. And what is D? In option D, we are going to determine the number of ordered quadruples A, B, C, D for which P is 98 less than a multiple of 100. Condition is already given. It is going to be 98 less than a multiple of 100. Okay. And remember this A, B, C, D, it can be any value and it can have same values also. The variables can have same variables also from 1 to 9. Okay, remember that. So I'll solve it in the whiteboard. This is little huge. This question is little huge. I'll try my best. Okay. So P is A, B, C, D. Okay, let's assume this is equation 1 first. And also they told you that it is 98 less than the multiple of 100, which means P is equal to 100 x plus 02, right? So this is going to be the equation 2. So from this we can say the last two digits of the P are 02. Last two digits are 02. Okay. You try substituting some values for x. You will get it. For example, if you substitute 1, you will have 102 as the answer. If you substitute x as 2, you will have 200 plus 02, which is 202. So you will always end up having 02 as the last two digits. Okay, I hope it is clear. So you will always have the last two digits as 02 in this. And we already know this 1, 2, 3, 4, 5, 6, 8, 9. These are the integers given. And we are going to predict the factors of P from this. I'll tell you how. Since the last two digits of the P are 0 and 2, it is not divisible by 5 or 4 or 8. I'll tell you why. If you're having 102, if you divide 102 by 5, you will have the remainder as 2, isn't it? If you try to divide 102 by 4, still you will have the remainder as 2 only. If you try to divide it by 8 also, you will have the remainder as 2 only. You can't, this is not a perfect division. You will get some remainder always. So 5, 4, 8, these are not suitable. Okay. Since the last two digits of the P ends with 02, you can call P as even. Okay. P is going to be even. So what are the even options you're having? You do have 2, 4, 6, 8. We already knew 4 and 8 is not possible. Okay. So either it is going to be P is even, right? P is even. So it is divisible by 2 or 6. Okay. So it is divisible by 2 or 6. I hope it is clear. Which means one among A, B, C, D is going to be 2 or 6. Just one. One among A, B, C, D is going to be 2 or 6. The remaining is going to be 1, 3, 7, 9. Okay. Definitely it is not going to be 5, 4 and 8. Okay. Only these options. It's going to be 2 or 6 or 1379. The answer for the quadruples are going to be from these 6 numbers. Okay. So we will be doing this like a trial and error only. Okay. You won't be getting the answer, exact answer. We will do some trial and error first. So till here it is, I hope it is clear. I hope you understood the equation 2. In equation 2, you do have last 2 digits as 0, 2. And from that 0, 2, you can conclude the P is not divisible by 5, 4 and 8. Okay. So you have the other 7 remaining numbers. Okay. So since P is even, we can say it is divisible by 2 or 6. One among A, B, C, D could be 2 or 6. So you do have the remaining digits 1, 3, 7 and 9. Okay. So that is for the rest of the 3. Right. So let's take these 2 first. Let's take 2 or 6 first. We'll try to solve it. You do have A, B, C, D, right? Let's assume A as 2 and A as 6. We'll try to solve it. Okay. Let me erase these. Okay, I'll just. You know what is equation 1P is equal to ABCD, and equation 2 was 100x plus 0, 2. This was your equation 2, right? So let me substitute equation 1 in equation 2. I'll have ABCD is equal to 100x plus 0, 2. Okay, so we already knew it is divisible. P is even and it is divisible by 2 and 6. 2 or 6. Okay, so if A is equal to 2, say A is equal to 2, you will have 2BCD is equal to 100x plus 0, 2. So try to take the 2 outside of it. It's going to be 50x plus 0, 1. You will have 2BCD. So 2 and 2 will cut. BCD is equal to 50x plus 0, 1. Okay. So it is 50x plus 0, 1. So try substituting some different integers, some different positive integers over x and see what is the last 2 digits of the BCD. Okay. From this equation, you are going to find the last 2 digits of BCD. Okay. So last 2 digits of BCD, Px plus 0, 1. So if I substitute 1 in x, what happens? BCD is equal to 50. If I substitute x as 2, I'll have BCD as 101. If I substitute x as 3, I will have my BCD as 50 times 3, 150. 150 plus 0, 1 is going to be 151. So if I substitute 4, I will have BCD as 201. So if you check for the repetition of the answer, you will always end up having 51 or 01 as the last 2 digits of BCD. You will always have 51 or 01. Okay. So the last 2 digits of the BCD, last 2 digits of the BCD is going to be 01 or 51. Yes. I hope it is clear. So this is by substituting A as 2. We already knew we are going to divide it by 2 or 6. Okay, let's try 6. Say A equal to 6. You will have 6BCD is equal to 100x plus 0, 2. Okay, I'm substituting over that. So try substituting some least values and see. What if you substitute 0 here? You will have 6BCD as 0, 2. Okay. What if you substitute 1? It's gonna be, I mean, you can't substitute 0. Maybe we'll try substituting 1, 2, 3, because you can only substitute some positive integer. So 6BCD gonna be 102 when x is 1. When x is 2, it's gonna be 202. When x is 3, the 6BCD gonna be 302. So you will always have the last two digits as 0. You substitute any positive integer, you will always have the 02 as the last two digits, right? Let's take only unit digit from this. Okay, let's take only unit digit. I think the last two digit. Okay, what if you substitute 100, 100? Yes, yes, yes. You will get this only. Let's take only unit digit from this. Unit digit of 6BCD is 2. I'm taking only unit digit. Okay, the last digit. We'll always have 2 only from this. Okay. So let's substitute the least value in this. What is the least value? The least value is 1. So if you substitute 1, you will have 102. If you substitute more than that, you will have some value which is greater than 102. And we know what a 6BCD is. 6BCD is P. So from this I can say P is greater than or equal to 102. Okay. Remember this. P is greater than or equal to 102. So now you see when you will get the unit digit as 2. I have told you, you will always get the unit digit as 2. So when you will get, um, multiplying which integer with 6, you will get the unit digit as 2 in your answer. Okay. So let's assume this is some variable, like, I mean, some y or something is equal to some answer 2. So what would be my y? 6 2s are 12, right? So that time I'll get my unit digit as 2. And also I can say 6 7s are 42. That time also I'll get my unit digit as 2. So it is going to be the unit digit of the, because I'm worrying only about the unit digit, right? So the unit digit of the 6BCD should be 2 or 7. Okay. The unit digit of the BCD should be 2 or 7. Let's proceed from here. Please note it down or take a screenshot. Okay, I'll erase this and proceed it from here, from 6BCD. I hope it is clear so far. So for 6BCD, I'm taking only BCD. BCD unit digit should be 2 or 7. Okay. So I can write BCD as 10Q plus 2. Okay. Or BCD is equal to 10Q plus 7. What do you mean by 10Q? 10Q is nothing but just tens place. Okay. So tens place is 10Q here. So unit digit is 2, unit digit is 7. So this is how I'm deriving the equations. So we know 6BCD, right? Which means you just have to multiply both the side by 6. So this becomes like this. And here it becomes like this. Okay. So from this you can say 6BCD minus 12 is equal to 60Q. 6BCD minus 42 is equal to 60Q. Okay. And what is the 6BCD? It is P, right? A, B, C, D is P, isn't it? So P minus 42 is equal to 60Q. Okay. So you have P minus 12 and P minus 42. So we already assumed the value of P is 102. P was greater than or equal to 102. I hope you remember that. So if I substitute that 102 here, I will have 102 minus 12 will become 90 equal to 60Q. Here, I will have 102 minus 42. 60 is equal to 60Q. So here you will have Q as 1. And here you will have Q as some decimal, right? So we'll ignore the decimal. You can choose the positive integer, which means the BCD is this. I mean, the BCD is this. Because you are not allowed to choose this, you are getting the Q as 3 by 2. Okay. So here you are getting some positive integer. So you can choose BCD as 10Q plus 7. Okay. I hope it is clear. I will write BCD equal to 10Q plus 7. Last two digits of 60Q. $60, right? You can also write 60Q as 10 into 6Q equal to 60. So now the last two digits are 60. So when you will get 60 as the last two digits, that is how you should check. When you will get 60 as the last two digits. Okay. So if you substitute Q as 1, you will have 10 into 6, you will get 60. Like 060. You can say the last two digits are 60. When you substituted Q as 1, you are getting the last two digits as 60. Okay. Try substituting Q as 2. You will have 6 2s are 12. 12 into 10 is 120. You are not getting 60 in the last two digit. So Q is equal to 2. 2 is not possible. Try substituting 3. You will get 180. Try substituting 4. You will get 240. Like that. If you substitute and you substitute 6. 6 6 are 36. 36 into 10 will give you 360. Okay. In 360 also, you are getting 60 in the last digit. So when you substituted 1 and 6, you are getting the last two digits as 60, right? So Q's unit digit is 1 or 6. Okay, it's supposed to be 1 or 6. So now you're going to substitute this 1 or 6 over here. Okay, over here. So BCD is equal to 10Q plus 7. So say Q equal to 1, you will have BCD is equal to 17. Okay. Substitute Q as 6. You will have 60 plus 7, 67, right? Like this becomes 10 into 6, 60, 60 plus 7, 67. So you will get 17 or 67. So the last two digits of the BCD are, the last two digits of the BCD are 17 or 67. So far, you have 0, 1, 51, 17, and 67. Okay. These are the last two digits of BCD. Okay. 1 minute. Okay. So by substituting 2 or 6, we are having these possible values. Whether the last two digits of the BCD are going to be 0, 1, 51, 17, or 67. These are the four possible answers when you substitute A as 2 or 6. Exclusively, you got this answer when you substitute A as 2. Okay, that's fine. So we do have some odd digits as well. You do have some odd integers as well. 1, 3, 5, 7, and 9. These are the remaining, right? So we have to assume some possible values of B, C, D from these odd choices. Okay. So for B, C, D, you're going to make some assumptions. This is also like a trial and error only. Okay. So what if B is 1, C is 1, and D is also 1? B, C, D will become 1, isn't it? We can also say 0, 1. So this satisfies. So B, C, D, 1. So when we had this option, when we set A as 2, you substituted A as 2, you got these two answers. You substituted A as 6, you got these two options, right? So you are getting the 0, 1 when you substituted A as 2. Okay. So A is equal to 2, B is equal to 1, C equal to 1, D is equal to 1. They're asking about the quadruples. What does it mean? It means 2 into 1 into 1 into 1, right? And also 1 into 2 into 1 into 1, like 1 into 1 into 2 into 1, and also 1 into 1 into 1 into 2. So these are the four possible options for this A, B, C, D value. Okay. So when you substitute A as 2 and B as 1, C as 1, D as 1, you are getting these four quadruples. All right. So let's see for some different values, because they're asking about all the possible values of P. So try substituting, only the quadruples, not the possible values. So try substituting B as 1 and C not equal to 1, D not equal to 1, which means you are going to substitute 3, 7, 9 from that. Okay. Let's make a table and see. I'm substituting B as 1, C is not equal to 1, D is not equal to 1. So if I draw a table of C, D, third column is going to be CD. Okay, CD, this is going to be CD. So we knew B is 1. So C and D is going to be, okay, 1, 3, 7, 9, right? So what if you have 3 here and 3 here? 3, 3, because you can assume same integers also. What if you have 3, 7? This becomes 9, 27. 3 and 9, it will become, okay, this is 21. 3 sevens are 21. You will have 27 here. What if it is 7, 7? You will have 49. What if it is 7 and 9? You will have 63. What if it is 9, 9? You will have 81. So what was the last two digits of the BCD? It was 01, 51, 17 and 67. So these are the last two digits, right? So just check, do you have anything like that? No matches, right? No matches. So let's try to change the values of it again. So try substituting BS3. Okay, I substituted BS1 here. What if I substitute my BS, because if I substitute BS1, CD, BCD both are same only, right? CD, BCD both are same because I'm substituting BS1 here. Okay, I hope you understood. So the last two digits of BCD are different from this, right? So now I'm going to substitute. Um, Now I'm going to substitute the value of BS3. Okay. If I substitute 3, I've substituted 1, I'm trying 3 now. Okay. If I substitute 3, BCD. 3 into CD going to be 3 9s are 27, 63. 3 into 27 is 81. 49 is 147. And you will have 189. And for the last one, you will have 243. So just check whether two digits, the last two digits are same or not. No, not yet. You're not getting anything. Okay. So let's try substituting 7 for B. Let's try substituting 7 for B. I'll draw another column. So this was not possible. Let's try substituting B as 7. 7 CD. I'm going to multiply 7 with this. Okay. I hope it is clear. 7 CD. I'm substituting B as 7 now. If I do that, okay, already, okay, this 3 definitely won't get the answer. You multiply it by 7. 7, 7 into 7 will have 343. 7 into 9 into 7 would be 441. 9 into 9 into 9 will be 567. Just multiply 7 with this. Okay. So again, you check the last two digits 01511767. Yes. Finally, you have 67 here. So this satisfy our condition, right? So 7CD, which means BCD 567. So B was 7 and C 9. For D, it is 9, right? So what about A? For A, we chose 2. For A, it is 2 and also 6, right? Okay, yeah, sorry. A was 2 for the first two option. A is supposed to be 6 for these two options, right? So A is supposed to be 6. So A is 6, B is 7, C is 9, and D is 9, which means 6, 7, 9, 9. Okay. So these options. So if you find the quadruples of this, if you try to shuffle it, like 6, 9, 7, 9, like 6, 9, 9, 7, like that, if you try to shuffle these by using permutations and combinations, you will have 12 options. Okay. You will have 12 options. So you will have 12 options of quadruples here. And already you do have that 4 options. Remember the 2, 1, 1, 1, 2, 1, 1, like that. You had 4 options. So 4 plus 12 will give you the answer as 16. Okay. 4 plus 12 will give you the answer as 16. So that's your result for the option D. I hope it is clear. I'll explain the option C in a different video.